Recording in progress.
Assalamu alaikum, dear students. I am Raja Shakeel, and today we are going to learn about the characteristics of sound. Wait for a few moments so that I can share the screen. All of the students are requested to switch on the cameras. If they are not switching on the cameras, they will be removed. So please be careful about it. Okay, dear students. So you had been learning about the sound waves. Previous to it, you had learned about the waves, and now we will be looking into the sound waves. And already you have got the concept of these sound waves. And now today we are going to learn about the characteristics of these sound waves. And again, if I want to repeat this thing, then what are the sound waves? That whenever you are creating any disturbance to any material on this earth, then you feel a special sensation into your ears, and that sensation is called as the sound. So now let's see toward the reading. Add here that when a speaker, when a loudspeaker cone is vibrating, it moves forward and backwards. You might have seen that the loudspeaker cone is vibrating. अगर आपने किसी जगह पे गए हों, शादी हॉल वगैरह में या ऐसी जगह पे जहाँ पे बड़े बड़े स्पीकर्स लगे होते हैं, then you might have seen कि उनकी बॉडी जो है वो हिल रही होती है. So its cone is vibrating, ठीक है ना? And so it moves forward and backwards. Actually, what is happening? That their bodies are moving forward and backwards. Usually for thousands of times within 1 second, hundreds or thousands of times in 1 second only. So it moves backwards and forwards and backwards, and then what is happening to it? That it is moving very fast. I've already told you that these are usually hundreds of times per second. So this speed is very high. So this squashes and stretches the air in front. So actually what is being done in the speaker, that this is actually pushing and pulling the air layer. So this area, since this area is vibrating, so what is being done in this area? So actually this thing is vibrating. Okay, and what is doing with it? That since the air is present around it, so it is actually pushing and pulling the air layers. And so air is at some places the air has been compressed. So for example, these are the places where the air has been compressed, while the other places which are having the rarefaction, those are called as. So these are the compression and the others are the rarefactions. So these white places are indicated as the rarefactions, while the blue places are indicated as the compressions. So these are not actual colors, but these are only for the impression. Although you can see that the sound waves can't be seen. So as a result, a series of compressions and rarefactions. So compressions are actually squashes. Compressions are squashes, and rarefactions, these are the stretches among the air columns, travel out through the air. These are sound waves. So these compression and rarefactions are actually the sound waves. when they reach your ears, they make your car, your eardrums vibrate and and you hear a sound. जब आपके ये ears से आके टकराते हैं, तो your ear is also having the same system. तो वो फिर उसमें क्या हो गया? It is having a sensation of vibration in it, and which is these waves are going towards your mind, and your brain is able to understand that this is a sound. If any student is having any question, that student may raise hand. And at here, Aisha Noor, you have to switch on the camera, otherwise I have to remove. And Shamir Khan, please switch on the camera. Okay, thank you. Okay, so what is the nature of these sound waves? Actually, these are pure energy. These are vibration moving through the air. Actually, the material is not moving. The particles of the medium, means the air, these are not moving. And the sound is not only moving through the air, but it can travel through the liquids. For example, it can travel through water, and even it can travel through the solids as well. So sound is not bound to the air, but it can be having any of the medium, either liquid or gas or solid. And but it must have the material medium for its propagation. If there is no material medium, means if it is vacuum, then the sound will be unable to travel through that vacuum. So anyhow, let's look toward the nature of the sound waves. So nature of sound waves. So the sound waves are caused by vibrations. So actually, if you are willing to generate sound, you need to create vibrations. So you must have the vibration. Vibration means the to and fro movements of somebody. That is called as the vibration, and that to and fro motion must be, usually the human beings are able to hear more than 20 times a second. And if somebody is vibrating for more than 20 times a second, means its frequency, if its frequency is 20 hertz, then he'll be able to hear, human beings are able to hear that sound, otherwise they'll be unable to hear that thing. So the vibration, so there must be a specific number of vibration per unit time. So the nature of sound waves, so any vibrating any vibrating body can be source of sound waves. So anything which is vibrating at a high speed, then that will be creating sound. So as well as loudspeaker cones, examples include vibrating guitar strings. For example, a guitar string is vibrating. So it is why the guitar string is generating the sound, because it is vibrating to and fro continuously within a second. So the vibrations, vibrating air inside a trumpet and the vibrating prongs of a tuning fork and so on. All of these, whatever you see around you, and the musical instruments and all of these things, these are called these are generating the sound. Also, when hard objects like such as cymbals and steel drums, so on, these are also struck, they vibrate and produce sound waves. So these are also able to produce these sound waves. I hope this concept is clear to you. Now we have to look into the there are two types of waves you have already learned. And what are those two types of what are those? One is longitudinal waves. Wait. Wait, dear students, there is an issue. Okay, sorry for the delay. So we are having two types of waves. What are those? One is longitudinal waves. So one type of the waves is longitudinal waves. They are also called as the compressional waves. While on the other hand, we have the other type of the waves. And what is that wave? That wave is actually the transverse waves. So longitudinal waves are usually, for example, these are sound waves. Sound waves are actually longitudinal waves. For example, sound. These are longitudinal or compressional waves. These are actually being generated by the compression and rarefactions of something, of some energy. And then that is the transverse waves. Transverse waves, actually, for example, these are water waves, waves on the water or ocean waves. So waves produced on the water. वो जो waves up down हो रही थी, up down. Okay, water waves. So actually, sound waves are moving left right. Means compression and rarefaction, left right. While the water waves or the transverse waves, they are moving up and down. Up down movement. They are having up down movement. Means what is that? Crests and troughs. Crests and troughs are being generated in on those waves. In those waves. While in longitudinal waves, these are compression and rarefactions. Compressions and rarefactions. I hope this concept is clear to you. Already you have learned about it. I know you have learned about it, but I was willing you to tell you in my own style. That's why. Anyhow, so this is the background for the waves. So what's in this topic, whatever has been written at here, that these sound waves are longitudinal waves. This is the first characteristic of the sound waves. So sound waves are actually, these are longitudinal waves. So means compression and rarefactions are traveling through the system. So these are actually longitudinal waves. So the air oscillates backwards and forwards, mean to and fro motion. As it means that the molecules of the air or layers of the air are having backward and forward movements as the compression and rarefactions are passed through it. So when they are passing through it, actually these are energy. Basically, these are energy, not the materials which are passing through it. When a compression passes, the air pressure rises. So what's meant by compression? Compression means something has been pressed, and due to this pressure, what is happening that the air pressure is rising at that place, at a certain place. So air pressure rises. When a rarefaction passes, the air pressure falls. So when there is a means compression is more pressure and rarefaction is less pressure. So the distance from one compression to the next is called as the wavelength. So if there is a distance between them, so what is a wavelength? Wavelength means length of a single wave. So for example, let's consider that this is the case in which this is a compression and there is another compression. So these are having a certain distance in between them. this distance, for example, let's consider these two things are having 1 millimeter distance in between them. So 1 millimeter, so this is the wavelength. So 1 millimeter is the wavelength. This is actually the distance between two compressions. But if you are going to measure the distance between two rarefactions, then the answer will be same. For example, this is a rarefaction. I'm showing in the green color. Okay, let's darken it. So this is the rarefaction. This is another rarefaction. Both of these are having a certain distance. If you check this distance, this distance will also be same as that of the distance between the compressions. So the distance between any two compressions, any two nearby compressions, or any two nearby rarefactions, that distance is always same, and so both of these will be called, though these distances will be called as the wavelength. I hope this concept is clear to you. Anyhow, so we had been learning about the nature of the sound waves. So first point is that the sound waves are having sound waves are longitudinal waves. The air oscillates between backwards and so on. So this is called as the compression to the next. So means the distance between any two compressions will be called as the wavelength. Next is we are having sound waves need a material to travel through it. So without a material, sound waves are unable to travel. Okay. For example, there are huge amount of the blasts which are occurring on the surface of the sun. So, but we are able to get the light. Although we are able to get the light and heat from the sun, but we are unable to receive the sound. Why? Because there is a vacuum in between Earth and the sun. That's why the sound is unable to travel from that place towards the Earth. So we need a medium for the propagation of sound. For example, at here on the left side, you can look into the diagram. This is an experiment designed for the checking of the movement of the sound waves. So what is that? That there is a container or jar which is filled with which was already filled with air, and this was then connected to the vacuum pump so that we can reduce the amount of the air. And it is having a bell, electric bell inside it. So electric bell has been shifted into the system. So it is connected to a battery or switch outside of the system. So wires are going into the system, and you are having this battery, means you are having a certain button outside of the system. And when you have switched on this bell, so bell will be ringing, and you will be able to hear the sound of the bell when the air is present inside the jar, inside this container. So after a few moments, if you are going to reduce the amount of the air, how? When you switch on the vacuum pump, so vacuum pump will be sucking the air from the system, and it will be throwing all of the air outside of the system. Means it will be throwing the air from the system into the environment. So that the pressure will be reducing inside the inside this system. So glass jar, inside the jar. So since the pressure is reduced, so you will be listening at reduced pressure. The sound will also be reducing. So pressure is reduced, means sound is also less. So you will be hearing less amount of the sound, means that will not be loud. And afterwards, when the whole of the pressure, whole of the air has been eliminated from the system, so what will happen? That since if the vacuum is created, after the creation of the vacuum, what is happening? That there is no sound. You will be unable to hear the sound outside of this jar. So there will, although you will be seeing that the bell is ringing, the bell is switched on, but no sound, zero sound. What's meant by this? That sound needs air or some other material to pass through it. If there is no air or no other material, and if there is only vacuum, then the sound will be unable to travel through that system. So what we can say that sound waves need a material medium to travel through this material is called a medium. So this material, any material through which the sound waves are passing. For example, if the sound waves are passing through air, then the air is a medium for that sound wave. If the sound waves are passing through water, then water is a medium, and so on. So this material medium is called a medium. Without it, there is nothing to pass on any oscillations. So these oscillations means vibrations of the body. These are unable to travel, then are not going to be converted into sound. So sound cannot travel through a vacuum, completely empty space. Vacuum means completely empty space when there is no air or anything else. Next characteristic is where dear students. So next characteristic is sound waves can travel through solids, liquids, and gases. I've already told you that they need a material medium. This material medium is not this is not a must for the air to for the sound to have the air only, but the sound may travel through water, through solids, other solids and liquids, and so they need a material only. The sound waves require a material medium. The material can be any solid or liquid or gas. So most sound waves reaching your ear have traveled through air, because they are traveling. Usually we are living in the environment of the air, that's why. But when we are looking into the ocean life or marine life, then what is that? The sound waves are traveling through the water in that system. But you can also hear when swimming underwater. If you are a swimmer, you might have, because I am having the experience that whenever somebody is talking outside of the water, then if I am swimming and my ears are inside the water, then I'm still able to hear their sounds. So when swimming underwater, and walls, windows, doors, and ceilings can all transmit pass on sound. So if you are swimming underwater, you can listen to the sound, and walls also. So sound can also travel through walls as well. But usually this is not your experience that the sound is traveling through walls. Actually, the walls are not so much good conductor of the sound, but just the walls can pass the sound through it. For example, if you are striking something with the wall, then the persons on the other side of the wall are able to hear that sound which is coming through the wall. So the wall is also and other solids, all of these solids and liquids and gases can be are the mediums for the sound. Then is sound waves can be reflected and refracted. Two things: reflection and refraction. Reflection is that when you are clapping at somewhere, for example, in the hilly areas, and you are again listening to that sound, hearing to that sound again. So the sound is actually reflected from the surfaces of the hills or the other stones or the cliffs. So the sound waves can be reflected, and they are refracted as well. Refracted means, what is meant by this? Refraction. you will be studying this concept in the next chapters and the next topics, but let me tell you that a refraction is the bending of a wave when bending or the changing of the path. Bend means to change the path. Of a wave when it moves from one medium to the other medium. I'm sorry, this has been vanished. Okay, it was deleted by mistake. So the bending of the waves when they travel from one medium to the other medium is called refraction. Anyhow, you will be getting the detail of this thing. So anyhow, since sound is a wave, so sound has the bending, or sound waves are having the refraction phenomenon attached to them. So sound waves can be diffracted. Here is another thing. Diffraction क्या चीज है? Diffraction is just, आप ये देखते हैं ना, अभी हम sound से जाते हैं light पे. So आप ये देखते हो बच्चों कि जी लाइट जो है जब आपके पास आ रही है, लाइट ट्रेवल्स इन स्ट्रेट पाथ, तो आप अगर उसको अपने लाइट्स को स्विच ऑफ कर दें दिन के टाइम पे, डे टाइम पे, और आप सन के सामने ना भी हो, फिर भी आपको अपने इर्द गिर्द जो है ना चीजें नजर आ रही, ठीक है ना. अभी डे टाइम है, आपकी लाइट्स भी ऑन ना हो, ठीक है, और आपका गेट ओपन हो, दरवाजा, आप डोर इज ओपन, ठीक है, व्हाट इज हैपनिंग दैट, और सन भी आपके सामने ना हो, मे बी कि दूसरी डायरेक्शन, हालांकि आपको पता है कि जी लाइट ट्रेवल्स इन द स्ट्रेट पाथ, लेकिन इसके बावजूद आप देखते हैं कि आप अपने इर्द गिर्द की चीजों को देख सकते हैं ड्यू टू द सनलाइट, हालांकि वो आपके सामने नहीं है. ये जो बेंडिंग है ना साउंड लाइट की, ठीक है ना, ये एक डिफरेंट कॉर्नर्स से होती है, यानी वॉल्स के कॉर्नर्स को टकराती हैं, फिर दीज आर having the corners of the doors and windows and so on. So they are striking those corners and then bending their path. They're bending from their path. This bending will be called as the what is this? Diffraction. So same thing is happening with the sound. आपको ये पता होगा कि दूसरे कमरे में बैठा है एक बंदा जो है ना, उसकी समटाइम्स आप आवाज सुन रहे होते हैं, साउंड सुन रहे होते हैं, हालांकि साउंड भी, इसका भी ट्रेंड यही है कि यूजुअली इट इज ट्रैवलिंग इन द स्ट्रेट पाथ, रिलेटिवली मोर स्ट्रेट पाथ, ठीक है. बट आप जो है ना दीवार के दूसरी तरफ भी बैठे हो, अगर वो जो है ना बहुत ज्यादा लेंथी नहीं है, तो आप बड़ा इजीली सुन रहे होते हैं दूसरे रूम में बैठे हुए लोगों को, या दूसरी वॉल के बैक साइड पे बैठे हुए लोगों को सुन रहे होते हैं. समटाइम्स यू आर लिसनिंग टू देम. Why? Because the sound can also bend through the corners. जब भी ये materials के corners को जब sound टकराती है, when it is having the it is striking to the corners of the walls or any other materials, then it is bending from that place, and this bending is called as the diffraction. So sound waves can be diffracted. They are able to be diffracted. So you can hear someone through an open window, यानी कि खुली खिड़की है और कहीं बाहर कोई बंदा बोल रहा है और वो आपके सामने भी नहीं खड़ा, फिर भी you are able to listen or able to hear to that sound, even if you cannot see them, यानी आपको नजर नहीं भी आ रहे हैं, फिर भी you are able to hear to them. This is because sound waves are diffracted by everyday objects. यानी हर ऑब्जेक्ट से वो डिफ्रैक्ट हो जाती है, मींस कि दे आर बेंडिंग एट द कॉर्नर्स. जब भी वो किसी भी साउंड वेव्स को जो है किसी भी चीज के कॉर्नर्स को टकराती हैं, तो दे बेंड और दे आर स्कैटरिंग मोर एंड मोर. दे स्प्रेड थ्रू गैप्स और बेंड राउंड. ये बेंड हो जाती हैं या फिर गैप्स बीच में जो होते हैं, होल्स होते हैं जहां जिन जगहों से, वहां से ये इजीली गुजर जाती है, ठीक है ना। और बेंड अराउंड ऑब्स्टेकल्स, ये ऑब्स्टेकल्स इतनी है ऑफ सिमिलर साइज टू देयर वेवलेंथ, तो ऐसी भी चीजें हैं कि जी जो कि बहुत बारीक भी हो, छोटे छोटे होल्स भी अगर होना वहां से भी गुजर जाती हैं, जो इनकी वेवलेंथ के इक्वल साइज के या इससे बड़े हो, ठीक है, और वेवलेंथ तो इनकी बहुत छोटी होती है। सो टिपिकली फ्रॉम अ फ्यू सेंटीमीटर्स, फ्यू सेंटीमीटर भी अगर कोई रास्ता ओपन है तो वहां से भी साउंड गुजर जाती है, टू अ फ्यू मीटर्स। सो ये बहुत स्मॉल जो जगह हैं, इट कैन पास थ्रू वेरी स्मॉल प्लेसेस एज वेल। Okay, Shamir Khan has raised hand. I think that he is willing to tell me that time is over. Okay, yes. Let me check that if we have done this topic or not. It has been completed or not. Okay, the topic is complete. So bacho, if you are having any question, you may raise hand, please. Otherwise, I'm going to end the lecture. Anybody having any question? Please raise hands. Okay, let me take the attendance. Okay. Wait. Osman Shiraz, your camera was not switched on, so you were not sitting before, your face was not clear. Shamir Khan, your face was not clear, so I think that your attendance will not be going to be marked. Okay, I'm going to end the lecture. Thank you very much, bacho. Very thanks, and Allah Hafiz. Okay. Thank you. Allah Hafiz.